today's new lesson is 9-6, permutations, and that is an arrangement or a listing of objects where order matters. I'm going to start in the bottom left-hand corner. If you were to think about what the teachers and Mrs. Writer in the office has to do to create your schedule. If we were to say you have 5 cores, I know technically you only have 4 because Lit's a 1 block, but we'll say you have 5 cores and 2 encores. The question is, how many different outcomes or how many different ways can they arrange your schedule? So we're saying we have 7 spots to fill. That's your first hour, second hour, third hour, fourth hour, fifth hour, sixth hour, seventh hour. And in the beginning, if they were to say, okay, well, let's fill your first hour, how many classes do they have to choose from? Well, they have 5 cores and 2 encores, so technically we have 7 classes to choose from. Well, once we choose one, whatever it is, how many classes do you have left for your second hour? So now we're talking about your second hour. Well, if you already have one here, you've taken 1 class, now you only have 6 classes to choose from. Your third hour, you've already used up 2, so now you're left with only 5 to choose from. And hopefully you can see this, times 4, times 3, times 2, and times 1. Then we take our handy dandy calculator and we're going to do 7 times 6 times 5 times 4 times 3 times 2. You can hit times 1, it's not going to change anything. And we are telling you there are basically 5,040 ways to arrange your schedule for school. Another one, I'm going to kind of still go with this one here. If I were to tell you there are 7 runners running in a race, and I just want to know how many different outcomes could be the first and the second place winner. So basically, I only need a first place winner and a second place winner. Notice for this one, I needed to fill up all 7 hours of the day, whereas this one, I only care about who is my first place winner and who is my second place winner. So before anyone crosses the line, there are 7 runners. So any 7 of them could come into first place. But once that one first kid runs through, how many kids are left to come into second place? And there's only 6 kids left. So there are basically 7 times 6 is 42 different outcomes that could happen. Next, we're going to come up here. Basically, the first number is going to tell you what number to start with. The second number is telling you how many spots. So the 3 is saying I have 3 spots to fill. And the 31 is saying, okay, the first one's going to be 31. The second one is going to go down by 1 because now there's 1 less, so 30. And the last one would be 29. And then I just take those 3 numbers and multiply them. So 31 times 30 times 29. And that gives me an answer of 26,970 different outcomes with this permutation. I'll show you one more of those again. This is now in your guided practice. So I'm going to jump over here because it's the same type of one we just did. Remember, the second number happens to tell you how many spots. It just happens to be the same. So 3 spots. The first number tells you what to start with. So 5 times 4 times 3. And then once I use all 3 spots, I'm done. 5 times 4 is 20 times 3 is 60. So the permutation would be 60. Now I'll jump back to the first question in your guided practice. In how many ways can a president, vice president, and secretary be randomly selected from a class of 25 students? So basically, how many different spots are there to fill? There is a president, there is a vice president, and then there is a secretary. So before anyone was chosen, there were 25 students. So we're going to write down that we have 25 students to choose from. After you choose a president, how many kids are left? Well, there are only 24 kids left. And once the vice president is chosen, how many kids are left to choose for the secretary? And that is 23. Then grab your calculator, 25 times 24 times 23. And there are a total of 13,800 different ways that you could do a president, vice president, and secretary in a class of 25 students.